It's my pleasure just to introduce Flore Gubert, who's presenting today together with their two co-authors, Dimitri and Esther, who will be online with us, answering clarifying questions, but also intervening at the end and as you wish. I think it's a great time for this paper because we are still in the mood of the Migration and Development Conference last week. So it's good to talk about migration in the setting of a developing country. So Flore, the floor is yours for 45 minutes, and thanks for accepting our invitation and for being online with us today.
Well, thanks for inviting me to present this paper about climate shocks and migration in Mali. So as you said, this is joint work with Dimitri Defrance and Esther Delesalle, which started at a time when both were postdoctoral students at the Espace Dev Research Unit for the first one and UCLouvain for the second one. It is still work in progress, so any comment and suggestions are highly appreciated. So the paper is, as you know, part of a growing literature investigating the impact of climate and environmental changes on human migration in developing economies. So I'm not sure I need to spend too much time on the motivations of the paper and the relevance of the topic, so I'll be very brief. If we look back in history, we learned that human mobility has been a frequent response to droughts in different settings and especially in Africa. For example, we can remember the effects of drought on Sahelian migration patterns in the 70s and 80s. These are well documented, as are the large-scale displacement that occurred in the Horn of Africa after the drought episodes of year 2011. Now, from the projections made by the IPCC, we also learned that West African Sahel is likely to be one of the most affected regions by climate and environmental change in the near future. So the combination of these two elements, that is evidence of drought-induced migration on the one hand, and drier and hotter years to come on the other hand, has resulted in very alarming newspaper headlines about the number of potential climatic migrants likely to request the protection and asylum in the next coming decades, which is usually illustrated by, by images of migrants undertaking highly dangerous journeys by crossing the sea over overcrowded boats from Africa to Europe. This also results in some alarming reports presenting climate change and migration as high security risks, with the Sahel in particular being considered as one of the hotspots because of environmentally induced migration. Yet, estimates of the volume of climate-induced migration are quite difficult to provide, and those contained in various reports coming either from the World Bank or from other institutions vary over quite a large range. This is probably due to the fact that it's quite hard to make a distinction between climate migrants and non-climate migrants, especially in areas where people are highly mobile and where labor migration is a norm rather than an exception. And I guess Sahel would be part of an example of such region where people just do not stop moving and move at each dry season. The other reason is due to the fact that environmental change and always interact with other drivers of migration, which can be cultural, which can be demographic, economic, political, social, and so on. So this multi-causality of migration makes it quite difficult to provide evidence of a direct link between environmental factors and population mobility in most cases. So what we want to do in this paper is to contribute to this debate by assessing whether and to what extent climate events, climate anomalies in Mali generates additional internal and international migration flows. And we also have as an objective to investigate whether there is a heterogeneity in migration responses to climate anomalies. So the question we try to answer is not only do climate anomalies ends up in increased mobility? I guess we all can have a guess on the answer, but also under which conditions do these anomalies translate into increased mobility? The final objective of the paper is to use our results based on recent decades in Mali to anticipate what might happen in the future. So Mali, a few words about Mali. So Mali is an interesting case to focus on for several reasons. First, Mali's economy heavily relies on agriculture. And for example, if one considers crop producers and livestock breeders, then no less than 2/3 of the population is engaged in agriculture. If we now consider only rural households, the fraction of their income coming from agricultural production has a median value of 70%, according to some recent estimates. Second, since it is mostly rain-fed agriculture, staple crop production is closely linked to rainfalls, with a very strong correlation of 0.73 between year-to-year differences, as suggested by the figure you have on the slide. Third, given Mali is a very big country, geographically speaking, and as a big country, it is characterized by a diversity of agroecological zones, referred to as the desert in the northern part of the country, as the Sahelian zone in the central part of the country, and as the Sudanese zone. And these different zones have highly different level of precipitation per year, which makes it possible to test for a difference in migration response to climate events, to climate anomalies, depending on affected individuals' place of residence. Four, Mali is characterized and has been characterized for many years by high migration rates, both internal and international. If you consider year 2010, for example, which marks the end of the period we study in the paper, 6.7% of Malians were living abroad. In 2009, which corresponds to the date of the latest population census, internal migrants represented 16% of the Malian population. Now, in terms of their destination, international migrants mainly go to neighboring countries, as shown by the map, which is on the left-hand side of the slide, with Côte d'Ivoire being by far the preferred destination of international migrants. You also have quite big numbers of migrants in France and in Spain, in a lesser extent. And what is suggested by the map, which is on the right-hand side of the slide, is that more recently, with the conflict that started in Mali in year 2012, there are some Malian refugees abroad, in Niger, in Mauritania, in Burkina Faso. But again, our study period ends before that, right? So we stopped in 2009, so we don't have these conflict issue intervening in our story. So obviously, this paper is not the first one to investigate the link between climate events and migration. So broadly speaking, if we look at existing studies, they can be broadly categorized in two categories, depending on their level of analysis and depending on the way they measure climate change or climate variability. So on the one hand, you have cross-country analysis, which rely on large panel of countries and use decennial averages of net migration flows over 30 or 40-year period. Some also use multi-country bilateral migration data. And on the other hand, we have micro or local studies. Both have some limitations, right? So if we consider the former ones using cross-panel data, they generally rely on aggregated variables and hence neglect within country heterogeneity, which can be significant. And in addition, there may be some confounding factor. They may falsely demonstrate a link between climate and migration. Turning to the second type of study, they are generally based on household surveys, hence covering a limited number of households and community, which restrains, in a sense, the diversity of observed climatic conditions. And another aspect that they generally rely on panel data with short time dimension, so that they fail to identify long-term trends in migration. So in order to try to overcome these limitations, what we do in this paper is we use population data that we took from the three latest population censuses conducted in Mali in 1987, 1998, and 2009. And basically what we do is we rely on population increments between censuses at a highly disaggregated level to infer net migration rates. And then we combine these data with climate data in order to assess the influence of weather events, weather anomalies, and migration patterns. Okay. We also use a migration module, which was introduced in the census in year 2009 to compute international migration rates at this highly disaggregated level, at the locality level. Let me now say a few words about our main climate indicator. So what we do is we use what is called the SPEI, that is the Standardized Precipitation Evapotranspiration Index, which is an index which takes precipitation, temperature, and evapotranspiration, that is the ability of the soil to retain water, basically, into account. This index is expressed in standard deviation above or below some historical values in a given location. Okay, so historical values are attached to a precise locality, a precise grid. Okay, so in our case, we will consider as a dry year, a year that is characterized by an average SPEI value of less than -1, and we compute the frequency of dry years or dry agricultural seasons between two censuses. I hope I was clear enough. So on these slides, what you have is, just to give you a quick overview of the situation, you have a figure that displays the average SPEI values for Mali over quite a long period of time, that is over the 1967-2009 period. So as you can see, the figure shows very large fluctuations over the period, with the strong dominance of dry events. As you can see also on the figure, anomalies are particularly striking in years 1973-1974, 80-84, and 2002, which corresponds to, we know this is well documented, to some drought episodes that hit Mali at that time. And actually SPE values during the growing season for these periods correspond to severe droughts. Outside these different sub-periods, average SPEI values are mostly negative, with a few exceptions. And this explains why in the paper, we will mainly focus on dry events in our analysis. We also consider, exceptionally high rainfalls, but we mainly focus on these dry events.
Sorry, just one quick clarification, perhaps. So why is it that there's no trend and that most values are below zero? It's not that you're computing this relative to the historical mean. So yeah, like on average, the dot should be around zero, right? Or the historical mean, some historical mean in the past.
Yes, the historical mean is computed. Maybe Esther can answer this, but it's a very long period of time. I guess it started in maybe Dimitri. I think it's year 2000, maybe in 1950 or even earlier than that.
Okay. Thanks.
Okay. Here on this map, what you have is.
Oh, sorry. Can I also ask you another question? Do you know whether the density of the ground weather station is sufficient and stable over time in Mali, or you have problems of changing coverage of the weather stations?
Dimitri, may I leave you with this question?
Yeah. For the weather, we use a reanalysis. It's OMB data, so it's ERA interim data. So it's based on the model, forecast model, and threshold rain gauges. So it's not on a way. We have a difference between the different year, but normally it's the same model for during the 1979 to 2015. It's the same model. It's one reanalysis. So it's not a bias by the rainfall the precipitation estimation.
Okay, thanks.
Yes, on this map, what you have is the distribution of SPEI values across the Malian territory in May 2009. And just to show you that there is indeed strong variation over the territory, right? Last, on the three maps, what you have is the frequency of dry agricultural seasons for each intercensal period for each Malian municipality. And what is very clear, if you compare the different periods, is that the 1987 period was on average much drier than the two subsequent ones. And the two subsequent ones are actually the one the two periods of our analysis, okay? Because unfortunately, we could not have access to the 1977 raw census data, okay? So we don't have this period. Right, now let me say a few words on our migration measures. So as I mentioned earlier, what we do is we use an indirect method, which is described in depth in Iqbal and Roy, to compute net migration rates at the locality level for different age cohorts. So since the different waves of the census are spaced by 11 years, we deduce that the population size of a given age group A in a locality J is expressed by the first equation you have. So just to take a simple example, we assume that, we have this equality that the number of individuals aged, say 20 in a given locality in the 2009 census should equal the number of individuals that were aged 9, that is 20 less 11, in that same locality in the previous census, in the 1998 census, time their survival rates over the next 11 years, plus the number of individuals aged 20 in 2009 who entered into the locality over the 1998-2009 period, that is between the two censuses, less the number of individuals aged 20 in 2009 who moved out of the locality between the 2 years, right? So from this equation, it's quite easy to get net migration for a given age cohort as the population increments between two censuses for this age cohort. Okay, I hope I was clear enough. It is, of course, a lower bound estimate of total migration flows because it does not take into account all the entries and exits undertaken by individuals inside the period. Okay, but it can be interpreted as a proxy for long-term or say permanent migration. Obviously, these measures raise some issues. First, instead of using 10-year forward survival rates for each age group, we do use 10-year forward survival rates for each age group. We use the survival rates from the statistic produced by the Population Division of the United Nations for Mali as a whole, while we would like this probability to be at least district specific, okay? Because we need to assume using these statistics at the country level, we need to rely on the assumption of mortality equality across locality, while mortality could be strongly impacted by extreme climatic events, okay? And so if this is so, if mortality is indeed impacted by climate anomalies, then we are underestimating the number of deaths in the intercensal period, and hence underestimating the locality's net intercensal migration. So what we do to try to measure these potential bias and to reduce it, if it's important, we first excluded age cohorts known to be highly vulnerable to drought events. That is the very young and the elderly. Okay, that's one thing we did. Okay, and then as a second check, we regressed the local mortality rates in the 12 months preceding the censuses on our shock variables, okay, to see whether our shock variables have an impact on mortality rates, and we found no significant effects. Okay, so I'm not saying that we have no more problem with this, but potentially this probably is not too important. Another issue we have is the fact that over this long period of time, between 1987 and 2009, some new localities were created and some existing ones were merged. And this leads to very unrealistic net migration rates, because it means that for year 2087, when new localities were created over time, for these localities in 1987, their population was 0. Okay, so what we did basically is we dropped these localities that were either created over the period or were merged over the period. Another issue has to do with what we call urban conurbations. Okay, urban conurbations are potentially composed of several urban localities. To give you a very simple example, the city of Kai, which is one of the regional capitals in Mali, is composed of 6 different urban localities. Okay, but we don't really care about migration within the capital city of Kai. Okay, so what we did is we opted to focus on migration between physically separated urban and rural localities. Okay, and so what we did is in the end, we aggregated those localities belonging to the same conurbation. So here is the results we get. So what you have on these two figures is net migration rates at the locality level for Maine, aged 20 to 69. So we aggregated, we considered all age cohorts together for the first intercensal period, that is between 1987 and 1998. So points in dark corresponds to positive net migration rates, which means that these localities recorded an increase in their population over the period, while points in light gray correspond to negative migration rates. In the next slide, you have exactly the same two maps, except that now it is the 1999-2009 period which is concerned, but it's the same sample of male aged 2069. As I said a bit earlier, we also used the 2009 census to compute annual international migration rates at this level of disaggregation at the locality level for the 2004 and 2009 period. Okay, we use a very simple question that has been included in this latest census, which is, are there any members of the household left over the 5 last years? And then if the answer is yes, we know the year of departure, we also know the sex of the individuals, and we know where he left, okay, in which country he left. And so this is what we use to compute our international migration rates, annual international migration rate at the locality level. And on this map, what you have is the results. So it's not very clear on these two maps because it's too small, but the size of the dots gives you a flavor of the value of the international migration rates. And here again, we aggregated the annual rates, so have international migration rate over the whole period, 2004-2009.
Flore?
Yeah.
Yeah, just a question about, in Mali, I guess that Mali must be subject to a strong phenomenon of rural-urban migration, still even in the modern period. So how do you account for that? So, which could be unrelated to climate change.
If you don't mind, I will answer really in a couple of minutes
okay,
when I present the specification of our model specification. Okay.
And related to that, your map seemed to suggest that immigration rates are also very strong from rural areas. So is it against the idea of Marchiori and co-authors that first you migrate internally and then you migrate due to climate change? You migrate first internally and then from cities you're going to immigrate internationally. Do you have evidence against that?
What I can tell you, what you points suggest is that you're talking about climate-induced migration, okay, which would be sequential, right? Starting with mobility first to urban areas and then abroad.
Yes, in the paper of Marchiori, it's what they claim. Yeah, they claim that this is the right process too.
Okay, so what I can tell you, it's not a completely satisfying answer. But in the case of Mali, it's quite rare to observe these sequential migration in general, right? So when people move, they move either internationally or internally, right? It's quite rare that they go to Bamako first or to some regional capital city and then decide upfront to move abroad. So this is for migration in general, right? So I don't really have the answer for climate-induced migration in particular, but yeah, I don't know. I don't know.
Okay, thanks.
Okay, so then to answer to your first question, let me first present you the model specification. So we actually run two types of regression on local net migration rate first, okay, which correspond to equation 1 on the slide, and on annual international migration rates, which correspond to equation 2, okay? So in the first equation, what we do is we have on the left-hand side our net migration rates estimated at the local level, okay, for the two intercensal periods. And we regress this variable on our drought measure computed over the intercensal period, plus an interactive term. So we systematically interact this drought variable with an urban dummy because we expect climate to have a differentiated effect on rural and urban localities. We have 3 censuses. We have 2 intercensal periods. So we are able to include locality fixed effects and period fixed effects. Okay? And these locality fixed effects capture, let's say, the average net migration rates of the locality, right, over this period of time ranging from 1987 to 2009, right? So what we aim to get with this specification is the delta of migration induced by drought episodes. Okay, I hope I am clear enough. In the second specification, what we do is we regress annual international migration rates at the locality level, again on the frequency of dry years in the last 5 years. And by contrast to the first specification, given the low occurrence of international moves at this highly disaggregated level, we could not disaggregate the figures by age cohorts, but we were still able to disaggregate it by sex, right? And by region of destination. I will be more explicit in a minute. So what you have on these first slides is our benchmark results for our male and female samples, whatever their age, using alternative measures of drought frequency, okay? The first 2 lines, the drought frequency is only drought during the agricultural season, ranging from June to October, right? The second next lines, we average SPE values computed on the whole years, right? So it corresponds to the frequency of dry years over the intercensal periods. And then the 2 last lines, well, as you can see, we can only consider the number of dry years from the oldest dry years out of these intercensal periods. So what you can observe on the slide is that in all the regressions, whatever the indicator that we use, drought frequency is found to have an impact on net migration rates, with quite significant differences between rural and urban localities. For males, to give you a flavor of important the size of the effect, one additional dry agricultural season is found to decrease net migration rates in rural localities by 3.5 percentage points, which correspond to a decrease of 26%, right? For females, the results are roughly similar, with an estimated decrease in net migration rates of 22%, okay? Now, if we now consider urban localities, the effect of drought episodes are much less pronounced in urban localities, at least for men, okay, which suggests that the effect of weather shock on migration mainly work through the agricultural channel. In the case of women, net migration rate is even found to increase by 2% in urban localities. So overall, these first results obtained using the whole samples of males and women suggest that when a given area is hit by dry episodes, these translate into a change in migration patterns in the localities situated in this area. Rural areas experience either a decrease in immigration or an increase in immigration, or both, okay? While the opposite is true in urban areas due to changing migration patterns among women. And this is true whatever the drought measure we use. Now we have the results by age cohorts, and by age cohort we get exactly the same patterns. Overall, we find that dry episodes significantly decrease net migration rates for both men and women in rural localities, and tend to increase or to decrease less net migration rates for women and sometimes for men in urban localities, okay, with a few exceptions. So this suggests indeed that dry events tend to accelerate rural-urban migration. So again, when we compare the size of the effects for different age cohorts, what we find is that the estimated change in net migration rate following one additional dry year is particularly strong for younger men, in those aged 20-29, which is quite expected given that it is this age where the propensity to migrate is found to be the highest in Mali. And then it progressively decreases with age. While for women, the percentage decrease in net migration rate is the strongest for the cohort age 30-39. okay? And there is no clear pattern with regards to age. Okay, so in the previous slides, you had the result for the 2029, 3039, and 4049 cohort, and here is for the older age cohort. On this slide, you have a table that displays our results using annual international migration rates. Okay, so as I said earlier, we are not able to disaggregate international migration rates by age, but we did disaggregate our data by main region of destination. Okay, and we did so in order to take distance as a proxy for migration costs. Okay, so we consider 4 groups of countries that are mutually exclusive: neighboring countries, that is countries sharing a frontier with Mali, other African countries, OECD countries excluding France, and France. Okay, remember when we had the map on the main destinations of international Malian migrants, we found that Côte d'Ivoire was one of the main destinations, and that France was also an important destination for Malian migrants. And so what we find is that if we consider all destinations together, we find that drought frequency in the last 5 years is found to increase international migration rates, except for OECD countries. And if we consider the first coefficient, that is the coefficient of, in column 1, the first line, the estimated coefficient suggests that one additional dry agricultural season in the last 5 years increases international migration rate by 0.19 percentage points, which correspond to a 15% increase. Okay, and if we compare these figure with the figure we got, depending on the destination, we find that the increase is much higher when one concentrates on migration outflows towards neighboring countries. The increase is plus 82%, and much lower when the focus is on outflows to non-neighboring African countries. Here you have the results after disaggregating the figures both for men on the one hand and women on the other hand. So we basically get the same kind of results. Obviously, I mean, maybe this is not so obvious, but international migration rates for women are much lower than for men, but we do find a significant climate effects for both samples. Okay, so before moving to some heterogeneity analysis, we conducted some robustness checks for unobserved common shocks. So what we did first is we included a full set of district by period fixed effects to adjust for all factors that could be common across localities within a given district by period. Okay. However, a concern with using these district by period fixed effects is that they, as you will see in a minute, they absorb a significant amount of weather variance. Okay, have a look at this table. What we did here is we regressed our SPEI variables under various sets of fixed effects. Okay, and what you have, the figures you have, is the R squared of these regressions. Okay, so we first use period fixed effect only, right? And then progressively added some fixed effects. So first of all, the locality fixed effects, then our interactive term district times periods fixed effects, and then another interactive term to at an even more disaggregated level, municipality times periods fixed effects. And as you can see, this confirmed that most of the variation in our SPEI values is captured by these different fixed effects. Okay, and hence the problem with this is that then the identification of climate effects rests on very slim margin once you add these set of district by period fixed effects in the regressions. Okay, and indeed, what you have here is the new results after introducing these district by period fixed effects, and the only significant result now is with men aged 2029. Otherwise, for the other results, we lose we cannot identify the effects, the climate effects. Okay. So, as an alternative, what we use is the interactive fixed effect estimator, which allows the error term to be composed of unobserved common factors that might be correlated with the regressors. Okay, so using these interactive fixed effect estimator, what we get is the following results. Okay, so what we have is in column 1 and 2, you have the result that we had previously with village locality fixed effect and period fixed effects. Okay, and then we add region per year fixed effect, the interactive term between region and year, district and year fixed effect, which absorbed most of the variation in our SPEI values. And then you have the results obtained using these interactive fixed effect estimator. Okay, and luckily enough, using these estimator, what you see that the results are roughly very similar to the one we have using the more classical fixed effect estimator. So I'm almost done. So then we push forward our analysis in order to test for the existence of between group or between region heterogeneity in climate effects. Okay, so by so doing, we aim at providing some insights into the mechanisms linking climate and migration. The fact that the differentiated effect we find for rural and urban localities suggests that the agricultural channel might be behind the result we have, but we wanted to push a bit further this assumption. Okay, so what we do first is we assess to what extent the agroecological context matters in this drought migration relationship. Okay, so our prior is that more favorable agroecological conditions are likely to be associated with a greater availability of effective in situ or on-farm adaptation strategies that may prevent hassles from using migration as a mechanism for coping with drought. Okay, so you would find the result here. So what we did is we simply interacted our drought frequency measure with, with the zones that I mentioned at the beginning of my talk. Here in this table, the arid zone is the reference category. And as you can see, indeed, the impact of drought is the strongest in arid areas and then declines progressively if you go from the northern part of the country to the southern part of the country. Okay. So there might be some tipping points in these arid areas, forcing people to migrate when hit by a dry episode. As a second stage, what we did is we took the degree of crop diversification into account with the objective of assessing whether in localities where crop diversification is the highest, whether an additional dry agricultural season has a negligible impact or the same impact as in areas where crop diversification is the lowest. Okay, and again, you will find the result here. And we do find some heterogeneity depending on our crop diversification index, right? In areas where crop are diversified, what you find is that the climate effects are almost negligible, right? While they are quite strong in places where diversification is lower. We finally test whether individuals' response to drought is wealth dependent. We know from the literature that there can be several channels, right? So it could be liquidity constraints that constrain people to migrate. So poor people could be lacking the abilities to migrate for lack of resources, but richer people could have also a better ability to cope with drought and so have a better capacity to stay in their region of origin. So we have different potential effects. So here, our wealth index is a composite indicator that we computed using household dwellings characteristics and asset ownership. Okay, and what we get is again a differentiated climate effects depending on wealth. Okay, with the wealth effect being the strongest for poorer localities and declining for localities in top quintiles. I know I'm running out of time, Simone, so I'll try to accelerate a little bit.
No worries.
I will just here show you some of the projections we conducted using our results. Okay, so very quick word on SPEI projections. I'm not a specialist and I'm sure Dimitri will complete what I'm saying. So what we use is cell level projections of precipitation, temperature, everything that goes into the SPEI index to compute projected version of our SPEI based indicators. Okay, and well, you have a flavor of what is expected for the future on the table, which shows that what is expected is, and this will not surprise you, an increase in the maximum number of climate shocks of drought episodes and an increase in the average number of climate shocks. And then we use our estimates, and to be more precise, we use the estimates we have in the first table that I described earlier. We use these estimates to compute the estimated number of additional migrants due to the drought episode that hit Malian rural localities over the second intercensal period. Okay, we then divide this number by 11 to get the volume of drought-induced migration in 1 year. And we basically replicate this exercise using the predicted number of droughts under two scenarios, what is usually called the friendly climate scenario and the pessimistic climate scenario. Okay, and the result we have are, what is on this figure is basically the estimated drought-induced net migration from rural areas here on the sample of men and women aged 20-69. So at the bottom of the figure, you have the net migration estimated on the second intercensal period, so between 1998 and 2009. So we get an increase of about 13,000 additional migrants. And if we use the projected SPEI for year 2038, 2058, and so on, what you see is that we expect an increase in this number, and we expect that this number to jump to 38,000 in year 2058, 2068. And if we now take into account the population projections of the United Nations to account for population growth in the next decades, we get an even higher number, as logically, right, of 135,000 additional net rural migrants in the most pessimistic scenario. Probably we'll come back to this during the discussion. What you have here is projected international migration outflows. So what we find using our estimated coefficients and the observed number of droughts at the locality level over the 2004 and 2009 period, this leads us to compute a figure of 2,000. 2,000 is the additional number of international migrants resulting from the dry episode that hits Mali over these 2004 and 2009 period. Okay, so what we do next is we use the projected SPEI values to have a flavor of what could be the number in the future, using different scenarios and including or excluding population growth. And we have the figures that you have on this table. I mean, the table is not complete because here it's only referring to the 2018-2038 period. Okay, very brief summary of results. So the paper suggests that for people in rural areas facing adverse climatic conditions, one of the options is to migrate to urban areas. There are other options, apparently, because we find differentiated climate effects depending on the agroecological zones, depending on the intensity of crop diversification, and so on. So there might be an important climate urbanization link, which has been emphasized in other papers. We also find some significant climate effects for international moves, whatever the country of destination, but the size of the effect is much, much smaller. And this leads us to say that even if we find an effect that is an underestimation of the total climate effects because of measurement issues, because we are very likely underestimating the international migration for different reasons, the picture we get is much less worrying than the current narrative suggests, right? There is so far only some suggestive evidence that agricultural productivity and rural incomes are the possible intermediate links between climate and migration. So just to give you a flavor of what we are planning to do in the coming weeks and months, our plan is to push a little bit further the analysis and interpretation of the heterogeneity in climate effects that we observe between the different livelihood zones that we have. And something we'd like to do is to identify and also characterize those localities in which effective net immigration rates are well above or well below the one that are predicted by our model, and see whether we can explain these either excessive or excess mobility or excess immobility. Is it because we have reached some tipping points? Is it because of the capacity of people to adapt locally? This is things that we want to investigate in the coming weeks. Thank you.
Thanks a lot, Flore. I have a long list of people that would like to ask questions. So Martin first, then Joan and Marlon, and then I will say the others. Martin.
Hi, Flore. Yeah, thank you so much for the talk. I wanted to ask you about the spatial correlation of these climatic shocks, so whether there could be actually strong spillovers across municipalities, and how this indeed would affect the estimates that you get. And a second question is about the fact that potential destination areas, so other municipalities far away, may also be affected by drought, right? So in a sense, you have multiple treatments at the same time.
Okay, I'm not sure I got your second question because that was for an unknown reason you were cut for some time. So maybe I will ask you to repeat the question, right? So spatial correlation, yes, for sure. So as I said, we try to draw for these serial or spatial correlation using the procedure by Xiang. I'm not sure we solved all the problems. Maybe my co-authors would have some compliments to make on this. And can you repeat your second question? If you
the second question is just the fact that the municipalities of destination of these migrants may have been also affected by these climatic shocks, right? So you have two forces acting at the same time.
Yeah, potentially. I mean, okay, so I'll try to clarify this. If you remember the map that I presented, the map of Mali with the different grids showing, the strong variation in SPI values over the territory. Clearly, I mean, it's not very precise data in the sense that it's square out of 50 kilometers, right? So you may have several localities within a given square, right? So the results suggest that when an area is hit by a shock, right, rural localities within this area tend to lose some population, and urban localities, it's not so clear that they tend to gain some population in the case of women and to lose a little bit, much less than rural localities for men, right? So, I mean, clearly, all the localities suffer from the same shocks, right? So you may have some counter effects, which suggests that in the end, given that we have differentiated climate effects between rural and urban localities, it suggests that maybe the effect goes through the agricultural channel, right? Since I mean, the effect is much more significant in rural localities than in urban localities.
Okay, Joan?
Yeah, I had a couple of questions. The first one is, I mean, basically, how we can think about your specifications is really a reduced form, right?
Sorry?
Your specification, your regressions is like a reduced form, right? So there's a drought or some severe droughts, what happens to migration rates, right? So I was wondering a little bit, what is your idea or your theory of migration decisions behind your results, right? So thinking about droughts may impact local economies, these may affect incomes of people with different wealth levels, etc., and how this translates into migration. So that's the first question. The second question that I had is more of a small concern, which is that the fact that droughts may affect directly survival probabilities, right? And to the extent that you use those to compute net migration rates, then, so I don't know if it's a concern or not, because I mean, as far as I can understand, the survival rates are at a more aggregate level. So perhaps this suggests that it's not a concern, but I would like you to share your thoughts on this concern.
Yeah. So on your first question, yes, we estimate reduced forms for sure. What we have in mind is that, again, that part of the effect goes through the agricultural channel. That is what we expect is, given the strong dependence of agriculture on rainfalls, what we have in mind is that if you have low rainfall, then you have a decrease in agricultural incomes, and then it increased the incentive to migrate for people, because this is one of the adaptation strategies. Okay, and this is, and to push a little bit further this idea, this is why we conducted these heterogeneity tests to see whether we find some results that are consistent with this story. Okay.
But can you add, or can you speak to, say, credit constraints or wealth effects, or, I mean, there's a myriad of potential channels. I'm not sure, I mean, so I understand it may be an ongoing process to put like all the results into a framework, but
the thing is, we are quite limited. I mean, given the data we have so far, I mean, census data, population data on the one hand, and climate data on the other hand, we are a little bit limited. Okay, we can try to get and this is where we are going now, try to get additional data coming from satellite data on crop diversification, on surface water, on extractive industries, to try to enrich our story, because I do agree that so far we are a little bit limited with the data we have. That's for sure. On your second question, I think I spent some time explaining why. So yeah, clearly using survival probability at the aggregate level is problematic, because we need to rest on the assumption that we have mortality equality over the whole Malian territory, which is clearly a very strong assumption and quite implausible assumption, especially in times of troubles, such as in times of droughts. We expect droughts to have potentially an impact on mortality rates, because we know that some people are highly vulnerable to droughts, and especially the very young and the very old. Okay, so that's why we decided to exclude these two age cohorts as a first step, right? We excluded the very young and we excluded the old ones. Okay, as a second test, what we did is thanks to the census data, we have an idea. We can compute mortality rates for the 12 months preceding the census. Okay, so clearly there are some under declaration. Okay, some newly born babies who died during delivery generally are not registered for whatever reason. A lot of deaths are not registered, but we assume that this measurement bias are orthogonal to our question. And so what we did is we computed these mortality rates at the locality level using the census data, right? And we regressed these local mortality rates on our frequency of drought measures, right? And we find no significant impact. So I didn't present the results, but it is in the paper, right? So yes, this is what we could do given the data at hand. So yeah.
Okay, thanks, Flore. There was Marlon and Cathy.
Hi, Flore. I'll be quite brief because we can talk for real later. and Esther actually has answered quite a few of my questions or comments. One thing that I was thinking that is I think related to Joan's first point is that you're more interested in emigration, but you have net migration, and you regress net migration on drought in that locality, right? But the effect that you find is partly driven by fewer people moving in or more people moving in. And so I was wondering whether that's part of the effect that you're interested in, or if it's not, then could you maybe control for some, I don't know, weighted average of shocks around, weighted by distance or weighted by past migration patterns to try to net that out and just get closer to the effect of droughts on emigration?
Yeah, this is something I need to think about. Yeah.
Okay, then I propose that we gather one further question by Cathy, and I let you interact live.
Okay, thanks. Hi, Flore.
Hi.
Thanks for your presentation. It's kind of a follow-up question to the previous comments on the mechanisms. If you want to go beyond reduced form and in particular explore the impacts on agricultural productivity, because they could come from many different sources, labor, health, and in particular land. So given the data you have long-run data, you could really look at soil degradation, I think, combine your data with soil quality data.
Yeah, the thing is, this is something we started investigating. We worked with experts in satellite imagery. What we discovered is that there is really a lack of consensus about how measuring land degradation, how to measure land degradation, right? And so some would favor the NDVI index, or other would favor land cover, or but it's in the end we found it very unclear which measure was the most relevant ones, given that we are working on Mali, and NDVI is not necessarily a good measure, a good index for a Sahelian country. So we are still exploring these things. Thank you for suggesting this. This is thing that we have in mind. The challenge, I would say, is that I think one of the strengths of the data we have used so far is that we can conduct really a highly disaggregated analysis, which is, I think, one of the originality of the paper. And we don't want to lose this capacity we have to conduct an analysis at such a highly disaggregated level. And so we have some trade-off to make between the precision of the data we have and the richness of the data we might find elsewhere.
In addition to NDVV, you have topsoil carbon content, as a measure of soil productivity. So I believe there are databases on this.
Okay.
But I mean, you are working with experts, so I guess you're exploring this.
Okay, thank you, Katie.
Thanks.
Okay, I'm sorry for interrupting the discussion. So I would like to thank Flore, Esther, and Dimitri for being online with us today.